Hello, and welcome back to algebra class. Today we're going to be talking about polynomials. Our objective today is to be able to find the degree of a polynomial and arrange it in descending order. First of all, we have to talk about what different type of polynomials we have. So the first type is a polynomial, which is a monomial or a sum of monomials. Next up, we have a binomial, which is two monomials put together. I like to remember that like a bicycle has two tires, a binomial has two terms. And finally, we have a trinomial. That is the sum of three monomials. So like a tricycle has three tires, a trinomial has three terms. Here's an example of two different monomials that we have. Notice there are no plus or minus signs. Here's an example of two binomials. Notice they are two monomials connected by plus or minus signs. And then we have two examples of trinomials. Notice they are three monomials connected together with plus or minus signs. So next up, we have to determine whether each expression is a polynomial. If it is a polynomial, we have to identify it as a monomial, binomial, or trinomial. So the first thing that we need to make sure to do is if we have any like terms, we need to make sure to combine those. So in our first example, we do not have any like terms, so we simply say we have one and two terms. So if there are two terms, that means it is going to be a polynomial, and that polynomial is going to be a binomial because it is two terms. Next up, we have a -8, which there's nothing we can do with that. That is just by itself. So that would be a monomial. In our next example, we have a 4a squared. We don't have any other a squareds. We do have a 5a and we have an a. Those two things are like terms. And we have a 9. So if I rewrite this, I can say 4a squared, and then I have 5a's plus another a is going to give me 6a's, and then I also have a plus 9. Now there are no more like terms that I can combine, so we can pretty easily see that we have 1, 2, 3 terms right there. So this thing is a trinomial. Now we want to write a polynomial for the area of the shaded region here. So to find the area, we need to take our big shape minus our small shape. And in this case, our big shape is a rectangle. So to find the area of the rectangle here, I need both the base and the height, which the base is b. We can see that the base is b. However, the height is actually going to be, if you notice, we have a r and we have another r here. So how many r's do we have to find the total height of the rectangle? That would be 2 r's. So to find this total area, we do the base times the height. So we have b times 2r. Then we subtract the area of our smaller shape, which in this case it is a circle. So to find the area of a circle, it is pi times your radius squared. So we say pi times our radius, which in this case is just r squared. And that is the area of the shaded region. We have the area of the big shape minus the area of the small shape. Here we do the same exact thing. We want to find a polynomial for the area of the shaded region. So once again, we do our area of our big shape which to find the area of our big rectangle here, we need to multiply the base times the height. So we say 4x times 2x. So 4x times 2x is going to be 8x squared. And then we need to find the area of our smaller shape, which is right here. So that's going to be 2x times x, which is going to give us 2x squared. Now, I have an 8x squared and I have a 2x squared. Those are like terms, so I can actually combine them. If I have 8x squareds minus 2x squareds, I actually have 6x squareds, would be the area of the shaded region. Next up, we need to talk about degrees of polynomials. So the degree of a monomial is the sum of the exponents of all its variables. So let's find the degree of each polynomial. So the first thing that I'm going to do for my first example is I have a 5mn. That m really has a 1 attached to it, but we don't write it usually. To find the degree of this polynomial, I know that if I add the 1 and the 2 together, that is 3. Now, I look to see what the highest degreed term is. In this case, we only have one term, so the degree of this polynomial is 3. On our next example, we have 1, 2, 3 terms. I have an x squared and a y squared, so 2 plus 2 is going to be 4. I have an x squared, so that's going to be 2. And the 5 has no exponents with it at all, so that's going to be 0. Now, the biggest degreed term that I have in this case is the 4, so that means that this is a degree 4 polynomial. Let's try our next one. We have 1, 2, 3, 4 terms. The a has a 1 attached to it, so that's a 1. The a and b both have 1, so add those together, you get 2. The a squared and b, that's going to be 3, and the 16 has a 0, because there's no exponents attached to it. The biggest degreed term here is 3, so this is a degree 3 polynomial. Next up, this says arrange the terms so that the powers of x are in descending order. So I care what exponent the x has with it. So I have 1, 2, 3, 4. So the x has a 2 with it here. I have no x's here, so that's 0. This x has a 1. This x has a 3. So I'm just going to arrange these in order from biggest to smallest. So I have negative 2x to the third. I have plus 6x squared. I have minus 8x. And I have plus 5. I have arranged them in order from biggest to smallest, so I'm all done. Next thing, I'm going to do the same thing for my x's. So I have 1 term, 2 terms, 3 terms, 4 terms. Here, my x has a degree 2. Here, I don't have any x's, so it's degree 0. Here, my x has degree 5. Here, my x has degree 1. So my first term I'm going to write is going to be that 4ax to the 5th. And then I say plus 3a to the third x squared. I have 9a squared x minus a to the 4th. Once again, that is in order for descending the powers of x. That is our last example for the day. Good luck on your homework.